Solving exponential equations using logarithms. All right, in the previous exponential equation video, we talked about solving exponential equations by finding a common base. In the beginning of that video, we talked about important facts about exponential equations. If you haven't watched that video, please do at least watch the very beginning of it where I go through this page. I'm going to give you a brief overview of it, but please do watch that. The big important things about exponential equations versus logarithmic equations were that we don't need to check our answers in the original equation with exponential equations because there are no domain restrictions for exponential equations. Another thing we will need to know for this particular technique that we're about to do right now is that we can take the log of both sides of an equation. So if I have m equal to n, I can take log base b on both sides. The more common thing to do is to take the ln on both sides. So this would be the same thing as ln m is equal to ln m. lmn, you know what I'm trying to say. You could take log base b, whatever base. The most common base we use is base b. We talked about the rule that log base b of b to the x is equal to x, that cancels each other out. In particular, ln of e to the x is equal to x. And then number 4 was used for finding common bases. All right, so let's talk about the procedure for solving exponential equations when they don't share a common base. If we have an exponential equation that doesn't have a common base on both sides, we use logarithms instead. All right, so like looking at these, like e and 3, those don't share a common base. 3 and 13, no common base. 16 and 25, no common base, right? 16 is 4 squared, 25 is 5 squared, but 4 and 5 are not the same number. The steps for this are taking the natural log on both sides of the equation. You can use any base log, but I like using ln because it's 2 letters as opposed to 3 letters or 4 letters if you have a different base. So that's what I use. We take the natural log on both sides, we take down the exponents, we solve the equation. Let's do it. We have 3 raised to the x minus 6 equal to 7. I am going to take the natural log on both sides. So we have ln of 3x raised to the x minus 6 is equal to ln of 7. This exponent right here can come down in front. Remember, one of our rules we have is that if you have ln of, or log base, whatever, of x to the c, that this is the same thing as c ln x, i.e. the c can come down in front. If you have an exponent on the inside, it can come down in front. When this comes down in front, it is going to come down in front with parentheses. So x minus 6 ln of 3 is equal to ln of 7. My goal is to get x by itself, this guy right here. 2 different ways to do it. The way I'm going to do it for this particular problem is starting by dividing both sides by ln 3. I now have x minus 6 equal to ln 7 divided by ln 3. You cannot simplify that. All right, don't simplify it. It doesn't simplify. Just leave it alone. I'm going to add 6 to both sides. I get x equal to ln 7 divided by ln 3 plus 6. It's an exact answer, and that's it. I'm done. So took the ln on both sides, isolated x. There we go. What's even better is when one of those sides is e. If one of your sides is base e, you're golden. I'm going to take the logarithm, the natural log, on both sides. So we have ln of e raised to the 8x is equal to ln of 2. Remember that fun thing I said on the page before where I said ln of e raised to the whatever is equal to the whatever. Yeah, well, that comes in handy here. Ln of e raised to the 8x is just 8x. These ln e's, the ln e portion cancels itself. You're left with 8x equals ln 2. To get the x by itself, no big deal. We'll just divide both sides by 8. So I get x equal to ln 2 divided by 8. Bam. All right. A few more. Almost there. That's it. All right. Let's stop using red for the ln thing. I'm going to use, it's too much. All right. So we have ln of 7 raised to the x plus 10 is equal to ln of 17 raised to the negative 8x. I am bringing my exponents down, right? Comes down in front, and comes down in front. If you have multiple terms in the exponent, they need to come down with parentheses. X plus 10 in parentheses. This negative 8x doesn't need parentheses because he's the only term up there. My goal is to get all of the x's on one side. So anything that has an x in it is going to come to one side. Everything else is going to go to the other. In order to do that, I'm going to need to take this ln 7 and distribute it to both terms. So we get x ln 7 plus 10 ln 7 is equal to negative 8x ln 17. Right now, there are two x's that I want to get on the same side together. This guy right here, this guy right here, and everything else on the other side. That means I'm gonna move him. I'm gonna move him to the other side so that both the x's are together, and then he can stay. So minus x ln 7 minus x ln 7. We get 10 ln 7 equal to negative 8x ln 17 minus x ln 7. At this point, you now have two terms on the right side that have x's in it. We can pull the x out. And by pull, I mean factor. Factor out the x. So I have 10 ln 7 equal to pulling out the x. When I pull that out, right, here's what's happening. When I pull out the x, that means that this x no longer exists in here, right? So all of this just scoots on over. He pulled it out front, and where is he now? He's right here. He's right here. If you distribute the x backwards, you're going to end up right back here, so we're good. To get the x completely by itself and get our final answer, we just divide by all this stuff here. We just take all this and we divide by it. Oops, not that color, this color. And I guess let me move you guys all over. Let's see, shrink. You're dividing by it on both sides. That looks awful, but it's just kind of what it is. Spend more time doctoring this than if I just did it the long way. All right, so you're dividing by all of that stuff so that you can just be done with it. You get a final answer of x equals over here. 10 ln 7, all divided by negative 8 ln 17 minus ln 7. That is our final answer. All right, one more. it's going to be the same process, all right? And I'm going to skip a step here. We know we're taking the ln on both sides, and we know we're going to have to take that exponent down in front. So when I take the ln on both sides here, I'm going to end up with 6x minus 1 out in front with an ln 5 because I took the ln on both sides, and then I take the exponent down. Here, x plus 2 will come down. We have ln 8. On both sides, we are distributing the logarithm. So I get 6x ln 5 minus ln 5 is equal to x ln 8 plus 2 ln 8. We want all x's on one side, everything without an x on the other. So I am going to move this guy, x ln 8. I'll move him over here. And then I will move the ln 5 to the other side as well. On the left side, we're left with 6x ln 5 minus x ln 8 equal to 2 ln 8 plus ln 5. Everything on the left-hand side has an x in it, so I am factoring an x out. I'm left with 6 ln 5 minus ln 8 equal to 2 ln 8 plus ln 5. To get x completely by itself, I am dividing both sides by this, by 6 ln 5 minus 8. 6 ln 5 minus ln 8. 6 ln 5 minus ln 8. Boom, boom. You are left with x equals 2 ln 8 plus ln 5, all divided by 6 ln 5 minus ln 8. It's just tedious. All right, that's what it is. It's tedious, but it's still doable. Keep your algebra, tight. Make sure that you're paying attention to what you're doing. You got this. I promise. Practice, practice, practice. You'll be fine. Whew. All right. That's all I have to say about solving exponential equations. That concludes all of the solving exponential equations and solving logarithmic equations. If you have questions, send me an email. Otherwise, I will see you in another video. Bye.